Okay, so come back to my channel once again. In this channel I'm showing you how to solve question paper questions, right? So we get straight to the questions that you get on your question papers, and I'm just showing you how to solve them, right? What is it that is required of you? What is it that you have to go back and study? What is it that you have to remember? And things like that. So here is another question that you are obviously going to get on your question paper, right? It says write 0.13 as a fraction. You're obviously going to get the question like this in your grade 10 question paper. It's more likely that you'll get it. Sometimes it's 3 marks, sometimes it's 4 marks. It depends on the question. So for this one, they gave it 3 marks. Okay, so first of all, what is this here? 0.13 with the dots on top. So what this basically means is that it's a notation, right? A notation is a way that we write things to simplify things for us, right? So just like when you know 10 to the exponent 6 equals to 1 and 6 zeros like this, 2, 3, 4, 5, 6 like this. This is the same as this. This here is the notation for this, right? So even this one here, 0.13 with dots, is a notation for 0.13, 13, 13, and so on and so on and so on. We don't know where it ends. It just goes on and on and on and on and on and on, right? Sometimes they can write it like this, 0.13, and then they put a dash like this. So this is still the same as 0.13, 13, 13, 13, and so on and so on and so on. What about 0.13 only with the dot on the 3? So this is only 3 is going to carry and go on and on and on and on, right? It's going to be 0.13, 3, 3, 3, 3, 3, 3, 3, right? Same as 0.13 with the dash on top of 3 only, right? So don't forget the notation here. They can give you in any form in your exam room or in your test. They can just put the dot, or they can put things like this, a dash on top, and so on and so on. Usually when they put a dash is when you have 0.1357 like this. Then this is going to be 0.1357, 1357, 1357, right? So, and so on and so on. So instead of them, the examiner putting a dots in each and every digit after the comma, he might use a line like this to simplify things, but they essentially mean the same thing. Okay, so this type of questions, they have they have difficulty levels, right? So for right now, let's start with the easiest one. The easiest one to solve, it's when they gave you something like 0.2, for example, and then they put a dot here and they say write it as a fraction. We all know that a fraction is something of this sort, right? A over b. A is your numerator and b is your denominator. You have a numerator and a denominator. 5 over 6 is a fraction, 3 over 2 is a fraction, and so on and so forth, right? So they want you to turn this thing into something of this sort. So this is what you're going to do. Let's start with this one right here, right? You're going to say let x equals to 0 comma 2, because remember I showed you that this dot here simply means the 2 goes on and on and on and on and on and on. So in this case, I want us to only increase it only 3 times. Even in your exam, I want you to increase it 3 times so that you can to recur it 3 times, so that it can be easy for you to work with. So let's put 2, 2, 2, and then let's say these 3 dots just shows it goes on and on and on and on, right? Let's label this equation 1, right? Again, this is another notation that you can use to show this is equation. You can write EQ here and then put 1 inside the bracket so that you don't confuse it with other numbers, or you can simply just leave it as 1 inside the circle, right, to show this is your equation 1. Why do we put it like this? It's because we're gonna have to create equation 2, right? So our aim, why we want to get equation 2, is we want to get something that will remain the same after a comma, right? Our equation 2 is something that will remain the same after a comma, but before a comma is a number of some sort, right? That is very important. The first step you do when you approach this type of questions is that you want the numbers after a comma to remain the same. If it was 131313, it must remain 131313. If it was 222, it must remain 2222. But the number before a comma on the left hand side of the comma, on the left side of the comma, right, you want it to be some sort of a number, right? So in order for us to get a number here that is not equals to 0, to get something that is not equals to 0 here, we can multiply this 0,22222 by something, right? So to simplify things, to make things simple for us, we're going to multiply by 10, right? And then after multiplying by 10, we check if this part here is still the same, and also this part here is some sort of a number, right? This is very important. If we multiply by 10 and this part here is still the same, is still 0.2,222, and the part before a comma is some sort of a number, then we are good. That is going to become our equation 2. But if we did not meet those conditions, then we're going to multiply by what? By 100. And if we did not meet it, we're going to multiply by what? By 1000, and so on and so on and so on and so on. You're just going to increase your zeros as you try to get to that condition, right? Remember, what is the condition that we want to meet? Conditions we want to meet is numbers remain the same after a comma, right, or your decimal point. Condition number 2, this is condition number 1. Condition means that the things that we want to achieve, right? Condition number 2 is that we want to get something, some number before a comma, perfect, which is not 0. Which isn't a 0, right? So as I said, we're going to say, okay, we're moving from here. This is our equation 1. Let me rewrite it again so that I don't confuse you. I said let x equals to, and by the way, my x is exactly the same as the one that we were given, except that we're going to put we're going to expand this thing according to whatever the is on top of our decimal value right there, right? So 0,2222. I said let's add 3 after the first one, right? Or you can add 2, still gonna work, but 3 is ideal. And then it goes on and on and on. You name this equation 1, right? So remember I said we're gonna multiply it by 10. We start by 10, right? So we say 10 multiplied by x equals to, in mathematics, what you do on the left hand side you also do on the right hand side, right? So I multiply my x by 10. I'm also going to multiply 0.22222 times 10, right? They are on different side of the equation sign, right? So I'm going to have 0,2222 times 10. All right, then let's use our calculator. So 10 multiplied by x is 10x, right? 10 multiplied, an apple multiplied by 10, it's 10 apples, right? Car multiplied by 10 is 10 cars. Yes, that's it. So let's see 0,22222 multiplied by 10. What is it that it gives us, right? Let's come here. 0,2222, right? Multiplied by 10. To give you some background with my calculator is that when a number like this 0,222222 goes on and on and on and on, my calculator is going to give me 0,2 and is going to put it in brackets like this, right? This does not mean it's a different answer, it's still the same as this one. It's just so happened that my calculator works like that, right? So let's say equals to, we get 2,222, right? So let me also do it again. 0.2222222 times 10. Maybe because this is a definite number, it doesn't put it in bracket as of yet. But if you see 2,2 and something inside the bracket, just know it's still the same as this one, right? It was just a background explanation of how it can behave sometimes. So cool. We multiplied that by 10. We got 2,2222. Right, so let's look at this. First of all, is this the same as this from our equation 1, which is the original number that they said we must convert? Yes, therefore we've met condition 1. It remained the same after a comma. Condition number 2, is this a number that is not the same as 0? Say some number before a comma, right? Before a comma, which isn't a 0. Yes, so we got the 2. Then we can name this our equation 2, right? So we can name this thing as our equation 2. So just to recap where we are right now, we were given 0,2 that has this thing on top. Then we changed it into 0,2222, right? And then we said, okay, let's make this our x. We said let x equals to 0,2222 and so forth, and then we named it our equation 1, right? So we use this pattern here whereby we multiply by 10 and then 100 and so on and so on and so on, such that we can meet these conditions right here, right? So we multiply it by 10, we got 10x equals to 2,222, and so on and so on, and we name this our equation 2, right? So we concluded that this have met our two conditions, only two conditions that we want to meet. We got a number before a comma, and then the number after a comma, it remained the same for both equation 1 and equation 2. Perfect. So now the reason why we name this thing equation 1 and equation 2 is because we want to subtract equation 1 from equation 2, right? We want to subtract this here from this here, right? So we're going to say whatever that's on the left hand side of the equation side, we subtract it. So what's on the left hand side? LHS RHS. We have 10x and x, so we're gonna say 10x minus x equals to 2,222 minus 0,2222. So as you can see, these 222, they're the same things, so they're gonna minus each other here, right? That's the reason why we use the same amount of digits after a comma. But in actuality, this thing goes on and on and on and on and on. Just don't forget that, right? So okay, 10x minus x, 10 apples minus 1 apple, x is the same as 1x, right? It's only 1. You can either say an apple or 1 apple. Same thing, you can say x or 1x, right? So 10 minus 1 is going to be 9x equals to 2,222 minus 0,22. As I said, the 222 will remove each other, then you only have 2. You divide both sides by 9. You want to be left with x, right? And 9 will cancel 9 in this side, then you have x equals to 2/9. This is supposed to be our final answer, right? But first of all, let's check with our calculator whether 2/9 is going to be 0,22222 and so on and so on, right? So let's see. 2/9, right, equals to 0,2 inside brackets. Remember, I told you earlier on that my calculator is going to write something like this. So this is the same as 0,22222, right? Then you got your full marks here. You're gonna get your 3 marks. All right, let's do another one, starting from scratch, right? So that you can remember what's going on here. I'm gonna do a similar example. I'm gonna, now let's pick 0,7. That's fine, 0,7 with a dot here. Remember, this is the same as 0,7 or with a dash on top, which is the same as 0,7777777, and so on and so on and so on. And remember, for simplicity, we're gonna stop at the third one, right? So we're gonna say, okay, fine, we're gonna let x equals to 0,7777, right? And then we're going to name this our equation 1, right? And remember, I said for equation 2 we're going to multiply by 10. And remember what our two conditions is that we want the next equation, we want the next equation to have same numbers after the decimal. In condition number 2, we want to have a non-zero, that is to say a number that is not 0 before the decimal. Decimal is your comma, right? Decimal is this comma right here. So let's begin. Let's multiply that by 10. 10 multiplied by x is going to be 10x, and 0,77777 multiplied by 10 is going to be 7,7777, right? You can use your calculator to see, to check, right? So did this meet the conditions here? Let's check. Is the same number after the decimal? Yes, we have 7,7777 both in both the equation 1 and equation 2, and we have a number that is not a 0 before a comma in equation 2. So then we can go to the next step. Remember what is the next stage? Is to say equation 2 minus equation 1. So what is on the left hand side of the equal sign must subtract each other, and what is on the right hand side of the equal sign must subtract each other. So we're going to have 10x minus x equals to 7,7777 minus 0,7777. And the reason why we picked the numbers that are equal is so that we know they're going to cancel each other, right? So we have 9x here, 10x minus x is 9x equals to 7,77 minus 0,777 and so on. These 7s will cancel each other. We are left with the 7, right? Then we divide by 9, then x equals to 7/9. Let's use a calculator once again and see if we're gonna get. Remember, my calculator has to give me 0,7 inside the bracket like this. So we're gonna say 7/9 equals to, and then I press SD, I get 0,7 like this. So this is going to give you a full 3 marks. I believe you're going to get a 1 mark for this, for coming up with this, and 1 mark for this right here, and 1 mark for the final answer. Right, so as I said, this kind of questions can get tricky. Remember, our first question was right 0,13, right? The procedure is still going to be the same, but the steps are going to increase, right? So now let's try 0,13. 0,13 recurring. Remember, they can write it as 0,13 with this on top, right? And essentially this is the same as 0,13, 13, 13, 13, 13. Do not make a mistake of writing 0,133333. Why? Because you have dots on top of both your decimals, right? So please don't make that mistake. So as you know, our first step is to let this equals to x, right? Let x equals to 0,13131313, right? If you look carefully here, I've repeated 1313 3 times after the original one, right after the first one. So just put that in mind. Then I'm going to put my 3 zeros here to show that it goes on and on and on, and then I'm going to name this equation 1. Then I'm going to, we're going to start multiplying it by 10. Remember, the reason why is because we want to meet what? these conditions right here. So I'm going to multiply it by 10. I'm going to say 10x equals to, let's see what it is. Let's go to our calculator and say 0.13131313 multiplied by 10. We get 1,3131313. Right? So you see we get 1,3131313. You can put a 1 and it goes on and on and on and on. This is our equation 2. When you look at equation 2, first of all, this is not the same as this, right? These are not equal, so we did not meet our condition right away. Yes, we have a number before a comma, which is the 1 here. It's a number that is a non-zero, right? But after a comma, these are not the same. So what do? We're going to say, okay, 10 by 10, we get the 100. Or you can just increase the zeros if you don't want to complicate yourself. But essentially is that you just multiply whatever that you had by 10, and so on and so on and so on. The first 10 and so on and so on and so on, right? So 100x, what we multiply by 100 is not this one. This one does no longer work, right? You can cancel it like this. It does no longer work. We go back to the first one. We multiply by 100. So 100 times x is 100x. And then 0,131313 by 100 multiplied by 100. Let's see, what do we get? 0.131313 times 100. We get 13,131313. You see, so we get 13,131313. Remember, it goes on and on and on and on. Then you can name this equation 3. Even if you didn't cancel this one, it's still fine. You can leave it like that as your equation 2. This is our equation 3. If we look at equation 3, did we meet our conditions? Yes, we did meet our conditions. Whatever that we have after a comma is the same here and there, and we have a number, some sort of a number before a comma. Then we are good to go, right? So that means we go to the next step, which we say equation 3 minus equation 1, right? So 100x, remember what's on the left hand side of the equation, subtract each other, right? Minus x is equals to 13,131313 minus 0,131313. 100x minus x, you're going to get your 99x, right? Is equals to, this part here is going to subtract each other. We have 13, right? 13 minus 0 is 13, right? Then you're going to divide this by 99, divide by 99, and then you get the reason why we divide by 99 is because we want to remain with x, which is supposed to be our final answer, right? So we're going to get x equals to 13 all over 99. Let's go to our calculator and see if this is going to be 0,13131313. Remember, this is good. This has to be the same as this here. Remember, the question says you have to write this in terms of fraction, right? Remember, the question says you have to write this in terms of fraction. And right now we got the fraction here, so we want to check if it's the same as that one, and my calculator, if it's the same, is going to give me 1 3 inside the brackets like this. Perfect. So let's check. 13 over 99 equals to Boom, you got it, right? So this is correct. So I assume for this one you will get 4 marks because there is an extra step here, but you can still get 3 marks depending on whatever the examiner think about that step, right? So just put that in mind. Let's try another one. Right, let's try another one. A new page here. So let's say you have 0,156 here, and then you have to repeat 56. 56 is recurring, so remember this is the same as 0,156. Sometimes you might get it like this, right? And this is essentially the same as 0,156. It's on top of 56, so only 56, 56, 56 will repeat as such, right? So we're gonna let our x equals to 0,156565656 like this, right? And then we're going to say, okay, this is our equation 1, and then we're gonna start with 10x, with 10, right? So we're gonna say, okay, 10x equals to whatever this multiplied by 10, right? So it's 0.156 times, okay, let me say 565656 multiplied by 10. So we get 1,56565656. We get 1,565656 565656 56. This is our equation 2, right? So let's you can see right away that, okay, fine, these two equations are not the same, right? We didn't meet the condition here. We have 565656, and here we have 156. Remember, here we have the 1. Let's try to multiply it by 100 then. So we're going to say 100 times x is 100x, and then we take the very same first equation, and then we say, okay, 0,1565656 times 100 is going to be 0.1565656 times 100. We're gonna get 15,656565 and so on. So we get 15,656565. This is our equation 3. Still, it doesn't match with equation 1. It doesn't even match with equation 2, right? So let's go to 1000 then. 1000. So 1000x is going to be equal to 0.1565656 times 1000, right? We get 156,565656. We get 156,565656. This is our equation 4. Right, if you look at equation 2 and equation 4, so far it's clear that we can never get a number that is the same as equation 1, right? We can never meet our condition based on equation 1, right? We only use our equation 1 as what? As our multiply. But if you look at equation 2, this one here and this one here, they meet our conditions, right? You have 1,565656, and we also have 156,565656. So both of this, after a comma, you have same digits. Before a comma, you have a number of some sort. It does not matter as long as one of the two equations have a number of some sort before a comma. But after a comma, your digits must be identical, right? They must be the same. So then it's safe to take equation 4 and subtract equation 2 from it, right? So we're gonna say, okay, 1000x minus 10x, right? This is our 10x on equation 2. This is 1000x on equation 4. Then we're gonna say this is equals to 156,565656. It's gonna subtract 1,565656 and so on, right? Because these are the same, they're going to cancel each other. So we're gonna have 1000x minus 10x is going to be 990, right? And then 990x is going to be the same as, because these cancel each other, 156 minus 1 is going to be 155. We're going to divide this by 990. 990 is going to cancel 990. What is the value of x? Is 155, all divided by 990. We want to check if this is going to give us 0,1565656, which in my calculator has to be 0,156 inside the brackets. But in your calculator, unless if it's programmed like mine, then it's going to be the same. But in your calculator, you must get 1565656 and so on. Perfect. So let's see. 155 all over 990. Perfect. We got our 0,156 is at the bracket. So this is your final answer. In this type of a question, they can give you 4 marks, right? Why 4 marks? Because the first equation here was just an anchor. We had to find 2 more equations through multiplication here, which have met our conditions. Remember our 2 conditions, right? Which have met our conditions, and then you can get your final mark right here, right? So you're not gonna get a mark for this. Maybe you might get it, but I would give a mark for this, for subtracting equations and cancel this one. Perfect. So hopefully you can see the pattern here. The pattern is that you take your first number, is your first equation, you multiply it until you get 2 equations that meet your conditions. You subtract each equation, 1 equation from the other, and then whatever that comes out as x is your final answer. Okay, sharp. If you have a question regarding this, if you have anything you want to put in the comment section, don't hesitate to do so. Yes.